6-5 Linear Inequalities. A linear inequality is the same thing as a linear equation, however we don't have the equal sign. We now, instead of the equal sign, have an inequality symbol, so a greater than, less than, greater than or equal to, or less than or equal to. We can find a solution of an inequality with two variables. It's still going to be an ordered pair, but it has to satisfy the inequality symbol. Alright, so we talked about in previous chapters when you have an inequality, for example, y is greater than 4, there are many solutions for y, whereas y equals 4, there's only one solution. So we can learn how to graph all of these solutions by solving the inequality system. Alright, so just a quick reminder, which inequality do you need to pay extra attention to when solving? Solving is getting the variable by itself. Well, here I would just subtract 3 from both sides and I get x is greater than 2. In this case, I subtract 3, but to get x by itself I need to divide by a -1 to both sides. When you do that with an inequality, don't forget that as you divide or multiply by a negative number, the inequality sign flips. This would be your answer. Keep that in mind as we work today. Alright, problem 1 is identifying a solution to an linear inequality. So again, they're going to give you an ordered pair. You need to plug it into the inequality they give you. Y is greater than x minus 3. I'm going to put 2 in for y, 1 in for x, solve. 2 is greater than 1 minus 3 is a -2. 2 is indeed greater than -2, so this is a solution. Let's try B. -7 in for y, -3 in for x, minus 3. Oops, I don't need the x in there. Sorry, -3 minus 3. -7 stays. -3 plus a -3 is -6. -7 is not greater than -6, so this ordered pair is not a solution. Alright, so now I talked about how we are going to graph all of the solutions to an inequality. Remember, there's more than one. Whenever you have an inequality symbol, a greater than or less than symbol, your line that you graph is going to be a dashed line. If you're graphing an inequality that has a greater than or equal to or less than or equal to, you are going to make a solid line. This is because if x is greater than or equal to 2, that means 2 is a solution, so it can be on that line, which is why it's filled in. If it was just greater than 6, 6 is not a solution on the line, so we just do a dotted line. We're also going to talk about where to shade. The shading is all of the possible solutions. We talked about there's more than one. We're going to shade on our graphs to tell you which ordered pairs are solutions. Alright. So if I need to graph y is greater than x minus 2, the first thing you're going to do is you're going to graph it as if it was an equation. So look at how they made the inequality sign an equal sign. So y equals x minus 2. I know how to graph that. That's in y equals mx plus b. I'm going to go down 2 on my y-axis. Oops. And then I'm going to go up 1 over 1. Alright, I'm going to try my hardest to do a nice line here, but it's going to be difficult. Pretty good. Missed a couple points. Alright, so there's my line. I made the inequality symbol an equal sign just temporarily. Oh, but I made a mistake. Since the inequality symbol is a greater than sign, my line, the points on the line are not solutions. I need to use a dashed line. Good thing I caught that. This might happen to you. So -2, still the same, up 1 over 1. But as I do this, it's going to be a dashed line. Yours will look better than mine. Alright, so we have the inequality graphed. Now the only other part is we need to shade all of the solutions. To do that, we need to test a point that is not on the line. For example, I could use any point that doesn't fall on my line. The easiest one to do, and I'm going to recommend you do it always look at the origin. The origin happens to not cross the line, so I'm going to use that as a possible solution. 0, 0 are the easiest numbers to work with equations. So I'm going to put 0, 0 into my inequality. 0 is greater than 0 minus 2. 0 is greater than minus 2. All right, 0 is bigger than negative 2. So that means that on my graph, wherever 0, 0, the side of the line that 0, 0 lands on, everything is a solution on the left and up side of this inequality line. All right, graphing a linear equality in one variable. We've looked at these equations before. X is greater than negative 1. That produces a vertical line at negative 1. You do the same thing where you test a point. They use 0, 0. They put 0 in for X. 0 is bigger than negative 1, so 0, 0 is the solution. So they shaded, if you see in yellow, everything to the right. Y is greater than or equal to 2 is a horizontal line at 2. They tested 0, 0. They put 0 in for y. 0 is greater than 2. Or sorry, 0 is not greater than 2. So since 0, 0 is not a solution, they shaded everything above the line. All right, so I'll just show you one more. X is less than negative 5. Well, I'm going to look at it as x equals negative 5. That line, if I go to negative 5, is at negative 5, and it's going to be a dashed line because it's a less than symbol. Now I need to know where to shade, so I'm going to put 0 in for x. 0 is less than negative 5. Well, 0 is actually greater than negative 5, so this tells me 0, 0 does not work in this inequality. I therefore need to shade everything to the left of my line. All right, sometimes you'll have an inequality that isn't quite yet ready to be graphed. In this case, just solve it for y so it looks like our y equals mx plus b form. One other trick for the shading part, if the symbol is less than or equal to, you're going to shade below the boundary line. And if the symbol is greater than or equal to, you're going to shade above it. Here's what I mean. If I graph this one, I'm going to look at it as an equation, y equals 3x plus 1, y-intercept of 1, up 1, 2, 3 over 1, 1, 2, 3 over 1. It's a greater than sign, so it's going to be a dashed line. And since it's a greater than symbol, I'm going to shade everything above the line. This over here would have been below, but here's my above. And I can also, if you're not sure, always just test the point 0, 0. 0 is greater than, 3 times 0 is 0 plus 1. 0 is greater than 1 is not true. Therefore, I shade where 0, 0 doesn't fall. In my line, it would actually go over here. So 0, 0 was not a solution. All right, here's a word problem. An interior decorator is going to remodel a kitchen. The wall above the stove and the counter are going to be redone. The owners can spend $420 or less. Write a linear inequality and graph the solutions. So they used X is going to be the cost per square foot of the wallpaper for this section, and Y is going to be the cost of the square feet of tiles. So they're since the tiled area is 12 feet, they did 12Y. Papered area is 24 feet, 24X. Add that together, it's got to be less than or equal to $420. So they solved their equation until they got it to equal just Y by itself. Then they can graph it using everything we've talked about before, and it will let you find the possible prices per square foot of wallpaper and tiles that will work for this budget. All right, and finally, sometimes you're going to be given an inequality system that's graphed, and you need to tell me what the inequality was. So what I want to do first is I'm looking at the line. It's solid. So I'm going to eliminate any choices that have a greater than or less than symbol. Not that one. These all have or equal to, so those could all be choices. All right, I'm going to look at the y-intercept of this line. Looks like it's at 1. And all three of these graphs have an intercept of 1, okay? What's my slope? Looks like I go up 1, 2 over 1. 2x plus 1. 2x plus 1, 2x plus 1. B does not agree with what I've found. All right, so it's between A and C, and the difference is the inequality symbol and which way I need to shade. So if this were my equation, I just need to find out what the symbol is. If I were to put 0, 0, because 0, 0 is not currently part of my line, looks like 0, 0 was a solution because they shaded it. So I put 0 in, 0, 2 times, oh, sorry, this is supposed to be a 0. 2 times 0, 0 plus 1. I need 0 to be less than 1 at the end. So my inequality is y is less than or equal to 2x plus 1, which is choice A. So just be really careful when you're looking at your graphs. All right, please complete the lesson check 1 through 4 for class.